we have to find the line to ground fault current at the terminal of the generator. This generator is star connected and it is grounded through a resistor of 1 ohm. So we will require the per unit value of this 1 ohm resistor. So first we will find this per unit value of this resistor. The given value of resistor is 1 ohm and Z base in this system will be 25 whole square upon 100. This is voltage base, kilovolt, voltage base in kilovolt. This is power base in MVA. 25 whole square, voltage base whole square upon power base will give the impedance base in ohm. So this is Z base and this is the actual value. So what is the per unit value? This is 1 divided by 25 whole square by 100, which is 0.16 per unit. So the 1 ohm grounding resistor has the per unit value of 0.16 for this system. To find the line to ground fault current at the terminal of generator, we will draw the positive sequence network of the generator. The positive sequence network of the generator is like this, in which a voltage source is present and positive sequence reactance is present. The positive sequence reactance of the generator is given J0.2, and since there is nothing is set about the voltage and loading of the generator, we will assume that the generator is working at no load rated voltage condition. Accordingly, this voltage will be 1 angle 0. We will assume no load rated, and according to that the voltage in this positive sequence network will be 1 angle 0. Similarly, the negative sequence network of the generator contains no voltage source. It contains only negative sequence reactance. And what is the value of negative sequence reactance given? It is J0.2. Now to find the zero sequence network of the generator, this is zero sequence network of the generator, in which the zero sequence reactance of the generator appears as J0.1. This is zero sequence reactance of the generator given in the problem. And since we have found the impedance in the we have found the per unit value of the impedance in the grounding, it will appear 3 times in zero sequence network. It will be 0.48 in this zero sequence network. We know that the grounding impedance Zn of the generator appears 3 Zn in zero sequence network. So this is positive sequence network of the generator, this is negative sequence network of the generator, and this is zero sequence network of the generator. For line to ground fault, we will connect this 3 sequence network into series. We will connect like this for line to ground fault. We know that in line to ground fault all the 3 sequence networks are connected in series. By connecting in series, we will find this current IAF0. What is this current IAF0? It is 1 angle 0 divided by 0.48 plus this, which is J0.5. So this is the value of this IAF0 in per unit. This is in per unit. So to find the fault current of this, to find the line to ground fault current at the terminal of generator, we will simply multiply the magnitude of this IAF0. We have found the IAF0 value. We will find the magnitude of IAF0 and multiply it with by 3 to find the actual fault current value. This will again be in per unit. What is the per unit value calculated? It is equal to IAF0. It is equal to, you can find the magnitude of this IAF0 and multiply it by 3. The per unit value will be 4.328 per unit. So the per unit value of line to ground fault current will be 4.328 per unit. How we have calculated? We have calculated IAF0 and the magnitude of this IAF0 we have calculated and multiplied IAF0, magnitude of IAF0 by 3 to find the fault current value. This is the per unit value of fault current. To find the actual value of fault current, we will multiply this per unit value by the current base. What is current base? It is 100 upon root 3 into 25. 100 is power base, 25 is voltage base. This is current base, and this per unit fault current into current base will give the actual fault current in kiloampere. So the correct answer will be 10 kiloampere.